Hello everyone, and welcome to Biopedia. Some of you may be familiar with the Cambrian Explosion, a period of about 10 million years from 535 to 525 million years ago, when around half of the world's extant phyla first appear in the fossil record. However, there is a biota which is less well known, but which actually came before the Cambrian Explosion. So, today, let's examine the Ediacaran fauna. The Ediacaran fauna is the first evidence for life visible to the naked eye which is beyond doubt. Specimens of this fauna were first found in the Ediacara Hills in Australia in 1946. The majority of their fossils are impressions found in sandstone. These organisms lived during the Ediacaran, or the period which lasted from around 635 to 541 million years ago, with the biota generally first listed as appearing between 580 and 560 million years ago depending on the source. In 2008, 272 species were known to science. The organisms of the Ediacaran biota were sessile organisms, shaped either like tubes or fronds, with no real differentiation of tissues or organs. They were soft-bodied and could become up to over a metre in length. There were significant changes in several atmospheric ratios after the biota evolved. These alterations are thought to be due to a doubling in oxygen concentrations in the atmosphere at this point in geological history. The Ediacaran biota then emerged due to these new favourable conditions. Now, the Ediacaran period sits within a series of ice ages which lasted from 750 to 590 million years ago. Specifically, the Ediacaran came just after the Marinoan glaciation, which was part of the snowball Earth period of Earth's history. The rise in oxygen levels both in the atmosphere and in the sea came at the same time as the glaciers and ice sheets from the Marinoan shrank. As an aside, repeated glaciations might have led to repeated boom and bust-like cycles in terms of genetic diversity. Animals may have diversified in the period before the final ice age, with the Ediacaran fauna only proliferating once the ice retreated again. To return to the remains of the fauna left behind, the fact that the Ediacaran fauna have been preserved through imprints is unusual, as this isn't really seen in the Cambrian fauna that appears later. It has been suggested that their ability to be preserved in sandstone, a sediment with large grains, indicates they may have had a body covering that was noticeably tough, rather like the chitin in the cell wall of a fungus. Attempts at classification based on comparison of morphology placed members of the fauna as mollusks, sponges, or cnidarians, and one of my sources notes that there seems to be consensus that the latter two are indeed members of this fauna. Bilaterally symmetrical organisms, which include all extant animals except sponges, cnidarians, and comb jellies, were apparently also a part of the Ediacaran biota. Evidence for this includes fossils, burrows, and embryos from the Ediacaran period, although there is apparently some dispute about the identity of the latter. However, members of the fauna have, over time, been classified as members of several different taxonomic groups across several different kingdoms, and a different viewpoint holds that they don't appear to be similar to other metazoans. It has previously been suggested that they should be placed within their own distinct kingdom, called the Vendobionta, which has supposedly proved controversial. The Ediacaran biota seems to have experienced a burst of radiation similar to the Cambrian Explosion, 33 million years later. A 2008 paper documents an analysis of the morphospace of the three fossil assemblages of the Ediacaran biota. Now, what morphospace means is all the various possible shapes that a taxonomic group of organisms can theoretically have. This study found that the morphospace of the three different Ediacaran fossil groups overlapped significantly, as well as having approximately the same range, despite varying taxonomically. This points to the greatest extent of this range having already been established by the time of the earliest fossil assemblage, known as the Avalon assemblage, which existed in deeper water habitats between 575 and 565 million years ago. morphospace appears to have increased rapidly in the Avalon fossils, with future Ediacaran evolution subsequently taking place within these defined boundaries of possible morphologies, without morphospace changing its size or range during that time. The authors felt that the explanation for this pattern was unlikely to be that there was a lot more of as-of-yet unknown fossil evidence from before the Avalon. Instead, they concluded that this narrative of rapid initial body plan diversification, with life subsequently evolving within a by then solidified morphospace, matches up with that of the later Cambrian Explosion. Growth in Ediacaran diversity stopped at about the time of the Cambrian Explosion, although the Ediacaran fauna may have survived into the Cambrian. Their decline may have been caused by the coevolution of predator and prey during the Cambrian period, with the less well-defended Ediacaran biota suffering the consequences. Alternatively, elevated oxygen levels before the Cambrian explosion might have allowed larger, more metabolically active organisms to emerge, while possibly simultaneously having an adverse impact on other organisms. Finally, developmental innovations such as microRNAs and Hox genes may have allowed new morphologies to emerge. Some have suggested that the Ediacaran fauna were the first animals that needed oxygen from the atmosphere to grow. In addition, their discovery is supposed to have reshaped our understanding of the pre-Cambrian geological era. They represent a much more complex form of life than people had previously thought to have occurred during this time. Moreover, the biota appears to consist of several attempts at multicellular life and larger body size, and was privy to the transition from a static microbial world to the highly dynamic world of the Cambrian and beyond. Although there is a debate as to the nature of the organisms it consists of, the Ediacaran biota has been noted as an important part of shaping the biological world as we know it today. As always, thank you for listening. Feel free to get in touch at the show's email address for any questions, comments, or topic suggestions for future episodes. Until next time, have a great week, everyone.